Okay, so we're continuing 9.5, our notes. We're looking at example 3. So yesterday we started finding the sums of geometric series. And I gave you a formula for finding geometric series. What was that formula? Just so I can write it on the board and we have it so that we can use it. What was that geometric series formula?
A1 times 1
A1 times 1
minus R to the N
minus R to the N
divided by 1
divided by 1
minus R.
minus R. So that was how we found the sum of finite geometric series. So that's important to remember that those are for the finite ones. If we had a finite series, what did that mean? Just so we can recap. So a finite geometric series has an ending point. It has a last term. That's going to become important later on in our lecture today. So looking at example 3, we want to find the sum of the finite geometric series. Now this time, rather than having the series listed out, where it's written in summation notation. So that's the summation notation for this series that we have in example 3. Ladies. So we need to find the sum of this series. So in order to find the sum of this series, what values do we need to plug into our formula? What are the values we need to know?
A1.
We need to know A1, we need to know R, and we need to know N. Those are our 3 values that we need to know. So we have to find those values in the summation notation. Yeah, Jack?
I thought N was always supposed to be 1. Under the...
That was
So
under
we're-
the arithmetic.
So that's what we're going to talk about.
Okay.
So Jack notices that down here on the bottom we have an n equals 0. When we were talking about our arithmetic series, our n at the bottom always, it was n equals 1 at the bottom. Geometric, they can write differently. They can start with a 0 if they want. So what that's going to mean when we go to find our n, that's going to change how we find our n. So let's start with our n value then. Before, with arithmetic series, when we were using summation notation, how did we find our n? What? It told us. We just used this top number, right? That told us how many terms we had in our series. Well now, where we're not starting at n equals 1, we have to change how we find that n value. So that was when I introduced you in with the arithmetic. To find that n value, you're going to take your top value, subtract your bottom value, and add 1. Remember we talked about that real briefly. Well, that would always work to find your n. You can use it with the arithmetics, you can use it with the geometrics. So we're actually, when you don't have that n equals 1 on the bottom, that's what you're going to use. So we're going to take the top for our n, subtract our bottom, and then we're going to add 1. So in this case, we're going to get 21.
Wait, so we subtract the 0, which is what's on the bottom,
Uh-huh.
and then where do we get the 1? Why do we add 1?
We add the 1 just because that's the formula for finding it, for finding that n value. That's just how you find it. So is everybody clear with how we find that n value for a geometric? Because that's going to be important. If you put 20, unfortunately you're going to get the rest of the problem wrong. So you need to know how to find that n value. So does that answer your question, Jack?
So we only do that if it's 0 or a different number?
Yes. It will always work even if you do use it with the 1, but we know that if the bottom is 1, then the top number is our number of terms. So you don't have to do it, but it will always work. we still need to find an A1 value and an R value in this summation notation. So if we think back to our original formula for finding geometric sequences, when we were finding specific terms in our geometric sequences, what was that formula? How did we find specific terms for geometric? The explicit formula. So what was that explicit formula? So we had AN equals A1
times R
times R
and minus 1.
to the n minus 1. So if we look at this formula, and we look at the formula that we're given for our summation notation, do we see any similarities? Can we kind of infer something about those two formulas? Because remember, this formula inside the summation notation is how we find our terms in our series, right? We're just plugging in these n values that we're given to find our series if we wanted to expand it. So looking at these two formulas, what can we call this for?
The A1.
That 4 is our A1 value. And then if that's our A1 value, what's this 1/2?
Count ratio.
That's our common ratio, or our R value. So using the summation notation to find these two values is actually really simple. You're just looking at those two terms. So in this case, our A1 is 4, and our R value is that 1/2. Now, if you didn't know that, you could write out a couple terms in your series. So if we wanted to write out a couple of terms in the series to expand this, if we wanted to find when n equals 0, we're going to plug 0 in to our n value here. So you're going to have 1/2 to the 0. What's 1/2 to the 0? It's 1. Anything to the 0 power is 1. So we have 1 times 4, which gives us 4. So that's our first term. So that worked. If we want to find our next term, we plugged in n is 0, so now our next term would be n when n is 1. So we're going to plug in a 1 here. So we have 1/2 to the 1, which is 1/2. So we have 1/2 times 4, which is 2. And then this would continue for all 20 terms. So if you didn't know that this was your A1 value, that this 4 was your A1 value, you could find your first term to make sure. If you didn't know that this 1/2 was your R value, we could, now that we have two terms, you could find your R value. But we can just tell by looking at the summation notation. So now we have those three values. So we're going to find the sum now of that series using our equation that we had yesterday. So we're going to plug those values in. So we're going to have 4 times 1 minus that 1/2 raised to the 21st power, all over 1 minus 1/2. And you can plug that into your calculator just like it looks there. And what are we getting? You're getting a fraction? Can you change it to a decimal?
8.
So it's telling you that it's approximately 8. So in your Inspires, it'll give you a decimal, and then if you change it to an exact answer, it'll give you 8. When I plugged this into my calculator, I got 7.999 and some more stuff after that. For our purposes, we want to round this to a whole number. So if we're rounding this to a whole number, That's how you get that 8. So you should get that it's approximately 8. All right, I want you guys to try example 4 on your own. It's another summation notation one that you have to find the sum of. So I want to see that you know how to do this. So try example 4.
Yeah. I don't know, I get it.
Yeah.
I'm gonna open it. Yeah, I don't think I see you notes.
No.
What does this say, like balloons or ice cream?
Because it's gonna be.
I got it.
No.
Yeah, I feel.
No, it'll be five.
I know.
It'll be 5, then
Did I say your face
it's
was
negative sign.
I mean, yeah.
He likes me, he really?
Negative 6.
Some wings.
Do you like
Write them
that?
down.
Be like, I'm gonna forget that.
I never asked them
I've
what
never
the
asked a boy
Yeah,
That's too long. Just throw it.
No, yeah, I know it's weak, but, yeah,
When have you
Yeah.
asked
yeah, not, I don't know.
Just say, I never had to ask them what it's from, so I'll just get over
They
it.
have supposed to be on.
So they have this as like
Okay. Yeah,
If you want to expand it so that you would have it written out.
like, and she was really,
Did you ask him today?
No, so that's what we
Today? You were good, you should ask him today.
I was supposed to say something. I was supposed to, he was supposed to come earlier. And I had it. But now he's going to cousin's play.
Well, he always does that.
Yeah, I don't know.
I was supposed to come to Rapids, but all of a sudden,
And you can do it for this one.
rain was driving his
We
van.
have that.
I don't know, it's just, okay. Here. No.
That's our word.
When we were finding,
But like, but we can just like go to his house, cause I hear somebody go.
Absolutely, that's my car.
so that one.
I guess most of them.
Um,
Would he he says no.
So when you
You'd
look
be
at
like,
that
well, you just ate it, come on. Please,
No, but
just
what do you
try
mean?
it.
What about the plus
I know.
one?
I didn't finish it.
Cause that's a good idea.
Wait, does he have a car?
Yeah.
Wait, why don't you just
Yeah, where do
write
you
a bunch
get
of
the
sticky
plus
notes
one?
and stick them all
Oh,
over
no,
the stick
no.
around?
No, yeah, how would that work?
Because his car is like his child.
On the window, on the window.
Five is,
Car.
That's A1. That's A1.
Because I was thinking something like that too. I was like, you could like,
Just
for his license, like his car or something. I was like,
So we use this one, so which term it doesn't specify.
just fill his car with
This doesn't say that.
fill it up with some balloons. Get a sign that says prom.
That's annoying.
Why? You just open it and all the balloons fly
I like the
away.
readers.
I know, me too.
I'm using all
But
these
it's
on my
just hard to get in the.
I don't know. But it's gonna be something. You guys want to do and then just negative numbers for this one. The last positive number.
Feel like, did you get a picture of his
Larger than all the others, but
picture of his
final
Yeah.
negative numbers.
Yeah, he is it.
Did you buy this today?
Yeah.
Do that, like,
I had to remind no.
I'd be like, no, I'm not.
Okay, so
You know.
I've been like, yeah, buddy.
for the N value. Right, but listen to that.
No, I got an idea. Be like, okay,
That's any.
be like, we're ordering meat on steak.
Okay.
It's not A.
Are we finishing up with example 4? Do we need more time?
Yeah, but I can do my securities on you.
This isn't even the right thing.
I missed that.
It's fine.
Yeah.
I thought if it was 0, then you had to do the 10 minus. If it was 1, it was just 1, right? Like this right here.
No, weird. I'd be like, you just wanna hang out.
So it would be 10.
Michelle's good at that. Yeah, get straight.
But, yeah, but if you subtract, you're gonna subtract the negative ball back. This is just telling you how, and it's how many terms you're looking at. So, because this line started at 0, and then it's 20 up here, that, like, this starts at 0, that adds on to it.
What are you doing after
Does
school?
that make sense? So this started at 5,
In the night.
and that was 20, and then it'd be 15, N would be 15.
Yeah, I think later.
It is right too, the A1, then the R, and then you just plug it in.
Yeah, so all you have to do is write it
It's so
down.
cheesy. I'm so stupid.
Like, have her write it.
Alright, so we're gonna look at example 4.
Have her write it.
So in order to find the sum of example 4, I need those same 3 values that I've needed this whole section. I need my A1, I need my R, and I need my N value. Looking at this summation notation, what values do I have? What's my A1 value? 5. That comes from right here. That's my A1 value. What's my R value? That comes from right here. And now for this one, what's my N value? 10. Remember, now this one, we have that N equals 1 on the bottom. So we can automatically say that this top number is the number of terms that we have. So that's a 10. So now we have our 3 terms. We can plug them into our formula. So we're going to have 5 times 1 minus. Now, when you have a negative R value, use parentheses. Because we're taking that negative 2 to the 10th power. When you plug that into your calculator, if you don't have those parentheses, you're not taking negative 2 to the 10th power. We've talked about that before with negatives. So make sure you're using parentheses. And then that's all over 1 minus the -2. Again, you should be able to plug that into your calculator exactly as it looks right there.
10 minus 1.
So we're using this formula. So in this case, we're just using that n value. So when you plug this into your calculator, what are you guys getting?
I just don't know how to like.
I got,
You put the wrong one?
I got 11 in. I also get this paper. Where'd you get the 1 from?
The A would be 4, right?
Where? What?
Yeah, the last problem was 20.
I got negative 1,705.
Oh, okay, so you're talking about finding that n value?
Yeah.
So we took the top
Zero. I know it's not.
minus the bottom, and then we added 1. So if we do the same thing for this one,
0.
you're gonna have that 10
Because you gotta count
minus
from 0 to
1, and then we're adding 1 back. So if we're subtracting 1 and adding 1, those cancel out, right? So you just end up with 10?
0 minus.
Why do you do that again?
That's how you find your n value.
1 minus.
That's how you find how many terms are in your series.
How come for example 3 you did -0 plus 1 instead of...
Because in our bottom we had n equals 0
Oh, okay.
instead of n equals 1.
Alright.
So it all depends on what you have for your bottom and your top. So what do we get when we plug this in? I saw you guys had it finished.
Negative 1,705.
So you get negative 1,705. I saw you guys had it done. You just don't want to give me an answer?
I did.
I know, and I thank
Was
you.
it 8?
Wait, I just
Was it 8?
Yeah.
Alright,
See?
so that's finding finite sums of geometric series using
I don't know.
the expanded versions and using summation notation. So now, with arithmetic series, we could only find the sum of finite arithmetic series. Geometric series are a little different. Depending on the geometric series, we can actually find the sum of infinite geometric series. So finding the sum of infinite geometric series is going to be different than finding the sum of the finite ones. So this formula that we have right here, this one is for finite. So that's for those series that have that last term, that n. There's a different formula for infinite. And how did we know a series was infinite? So it just keeps on going, right? We had that dot, dot, dot. So for an infinite series, an infinite geometric series, in order to find the sum, we're going to use this formula. However, there are two things that we have to figure out whether we can actually find the sum of the infinite geometric series or not. Because some we can find the sum for, and others we can't. So that goes into our definitions for converges and diverges. So this is kind of confusing, so I want to make sure that everyone's paying attention for this part. This is probably the hardest part of this section. If we're talking about something converging, what that means is you'll have an infinite series. So we'll have 1 plus 1/2 plus 1/4 plus dot, 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 right? That tells us that it continues, that we're adding numbers forever, right? So we have a series that looks like this. What that's saying is even though we're adding each of these numbers and we're continuing to add forever, that sum is still going to become a real number. It's not going to just continue to grow forever. So what it's saying for converging, your terms are going to start getting smaller, right? We noticed that they're getting smaller. 1/2 is smaller than 1. 1/4 is smaller than 1/2. Our numbers are going to continue to get smaller and smaller and smaller as we go down, right? Because that's going to be the pattern for a geometric series. We're multiplying by some number, and our numbers continue to get smaller. Well, our numbers are going to get so small that even though we're continuing to add something, that something that we're adding is insignificant. It's so small, it doesn't even matter that you're adding it. So you can continue adding, but it's still reaching some number. So for converges, an infinite series converges if the sum gets closer and closer to a real number.
No. Wait, I thought that was getting further from real numbers.
No, so we're continuing to add stuff, but we're going to get closer and closer to a real number. So rather than having it grow forever and ever and ever, adding those teeny tiny numbers aren't going to matter. So once we get to a certain point, it's just going to equal some number. So,
Because that's. What do you mean by real numbers?
so it's going to equal like 2 or 4. It'll add up to like a whole number, a regular, just whole number.
Okay. So then, isn't that going down to?
So yes, so okay, so we have numbers that are decreasing. They're getting smaller and smaller. So when you notice that you have a series, that your terms are getting smaller and smaller and smaller, that's going to mean that it's going to converge. Because you're going to have to be able to tell the difference between whether it converges or it diverges. You're going to be asked the question, does this series converge or does it diverge? So if you look at your terms and each term gets smaller, that's a convergent series. The way we look at that is it's all going to depend on your R value. So that common ratio that we talked about, that's what this is going to depend on. For converges, if your R value or the absolute value, we're going to talk about the absolute value because we want our R value to be positive when we're looking at these. We want the absolute value of our R to be less than 1. That's how we're going to tell. That's going to be our test to see if our series converges. So in this case, if we look at my little example series here, what's our R value?
The ratio. What's the
How do we
ratio?
find our ratio for this series?
Times 1.
So we're multiplying by 1/2. How did you find that?
1 times 1/2.
So 1 times 1/2. So this one you can tell. How else did we find that R value? Because they're not all going to be nice and neat like this that you can tell, oh, that's 1/2. Remember, to find that R value, you take your second value and you divide by your first value. So in this case, we have 1/2 divided by 1, which equals 1/2. So that gives us that common ratio. Being able to tell whether it converges or diverges depends on being able to find that R value. So you need to know how to find that R value. So if it converges, if you find out that your series converges, we're going to be able to use this formula that I just gave you. This is how we're going to find the sum for a convergent infinite series. Now, if your series diverges, in contrast, the only definition for diverges is that your series doesn't converge. So this means that your series,
Is that a series or a sum?
so we're specifically talking about the series.
So why is the converge the sum?
So no. So okay, a series converges when the sum gets closer and closer. So instead of just saying the sum, an infinite
Series is a sum. Series is
yeah, and a series is a sum.
So when the sum doesn't get closer and closer to a number, like how if you have fractions, how they're gonna get smaller and smaller and smaller, it's gonna get closer to a number. Okay. If it's not gonna be, if it's not gonna be a fraction, it's gonna get huge, bigger, bigger, bigger. So it doesn't get closer to a number, it's just gonna get infinite. And that's what.
So when do we use each sum?
Okay, pretty much.
So if your series does not converge, it diverges. If your series diverges, you cannot find the sum of it. So we can only find the sum for infinite series if it converges. So our analogy in first hour was if it converges, you can. If it diverges, you don't. So if that's an easier way for you to remember it. Converges, you can find the sum. Diverges, you don't find the sum.
And then you never. So we're looking at.
And then a note for the diverges. So just so when we're looking at those R values.
This one just gets smaller, this one just gets
For converges, we had the absolute of the R value was less than 1. For the diverges then, we're looking at the absolute value of R is greater than or equal to 1. So that's how you're going to tell the difference. You're going to look at the R value. Is it less than 1? Or is it greater than or equal to 1? That's going to be our test. Like I say, the converges, diverges is probably the most confusing part of this section, so we're going to work through it together. So those are just like the definitions that we're going to use. So converges, if it converges, we're going to find the sum with this equation. If it diverges, we're not going to find the sum. You cannot find the sum. So we're going to look at example 5. Example 5 will hopefully kind of help us out here. So example 5 is actually what I have right here. This 1 plus 1/2 plus 1/4. So we want to know, the question asks, does the series converge or diverge? Well, does it converge or diverge? It converges because we found that our R value was that 1/2, right? R equals 1/2. So if we want to take our test, we want to take the absolute value of that 1/2. What's the absolute value of 1/2? It's just 1/2, right? Absolute value just gets rid of that negative. So you should always, if you take the absolute value, you should always have a positive R value when you come out of that. Is that 1/2 less than, greater than, or equal to 1? What is it? It's less than. This is less than 1. 1/2 is less than 1. So what does that tell us then? That tells us that this series converges. So the next question says that if it does converge, what's the sum? So we just said that it converges. So now we're going to go over and use this equation to find the sum. So in this case, for this equation, we only need two values. We need an A1 value and an R value. Well, we already found our R value. What's our A1 value for this sequence?
1.
It's 1. So we're going to take those two values and plug them into this formula. So we're going to have 1 divided by 1 minus 1/2. And that's how we're going to find our sum. So when you plug that into your calculator, what do you get? So you get a sum of 2. So this infinite series, the sum equals 2. So even though we're continuing to add numbers, we're continuing to add numbers forever, it's only going to equal 2. So that's how we're using this converging and diverging. Does that make a little more sense now?
Yeah.
Yeah? You sure?